So I have a function here, h of n, and let's say that it explicitly defines the terms of a sequence. So let me make a quick table here. So we have n, and then we have h of n. When n is equal to 1, h of n is negative 31 minus 7 times 1 minus 1, which is going to be, this is just going to be 0, so it's going to be negative 31. When n is equal to 2, it's going to be negative 31 minus 7 times 2 minus 1. So 2 minus 1. Well, this is just going to be 1. So it's negative 31 minus 7, which is equal to negative 38. When n is equal to 3, it's going to be negative 31 minus 7 times 3 minus 1, which is just 2. So we're going to subtract 7 twice. So it's going to be negative 31 minus 14, which is equal to negative 45. So what do we see happening here? Well, we're starting at negative 31, and then we keep subtracting negative 7. We keep subtracting negative 7 from that. In fact, we subtract negative 7 one less than the term, we subtract negative 7 one less times than the term we're dealing with. If we're dealing with the third term, we subtract negative 7 twice. If we're dealing with the second term, we subtract negative 7 once. So this is all nice, but what I want you to do now is pause the video and see if you can define this exact same sequence. So the sequence here is you start at negative 31 and you keep subtracting negative 7. So negative 38, negative 45, the next one is going to be negative 52, and you go on and on and on. You keep subtracting negative 7. Can we define this sequence in terms of a recursive function? So why don't you have a go at that? All right, let's try to define it in terms of a recursive function. Let's just call that g of n. So g of n, and in some ways a recursive function is easier, because you could say, okay, look, the first term, when n is equal to 1, if n is equal to 1, let me just write it, if n is equal to 1, if n is equal to 1, what's g of n going to be? It's going to be negative 31, negative 31. And if n is greater than 1 and a whole number, so this is going to be defined for all positive integers, and whole number, well, it's just going to be the previous term, so g of n minus 1 minus 7. Minus 7. So we're saying, hey, if we're just picking an arbitrary term, we just have to look at the previous term and then subtract 7. And it all works out nice and easy because you keep looking at previous terms all the way until you get to the base case, which is when n is equal to 1, and then you can build up back from that and you get this exact same sequence. Let's do another example, but let's go the other way around. So here we have a sequence defined recursively, and I want to create a function that defines the sequence explicitly. So let's think about this. So one way to think about it, this sequence, when n is equal to 1, it starts at 9.6, and then every term is the previous term minus 0.1. So the second term is going to be the previous term minus 0.1. So it's going to be 9.5. Then you're going to go to 9.4. Then you're going to go to 9.3. We could keep going on and on and on. Or if we want, we can make a little table here. And we could say, this is n, this is h of n. And you see, when n is equal to 1, h of n is 9.6. When n is equal to 2, we're now in this case over here, it's going to be h of 2 minus 1. So it's going to be h of 1 minus 0.1. Well, it's just going to be this minus 0.1, which is going to be 9.5. When h is 3, it's going to be h of 2 minus 0.1. Minus 0.1. Well, h of 2 is right over here. You subtract a tenth, you're going to get 9.4. Exactly what we saw over here. So let's see if we can pause the video now and define this, create a function that constructs or defines this arithmetic sequence explicitly. Here it was recursively. We want to define it explicitly. All right, so let's just call it, I don't know, let's just call it f of n. And we could say, look, it's going to be 9.6, but we're going to subtract 0.1 depending a certain number of times depending on what term we're talking about. So we're going to subtract 0.1, but how many times are we going to subtract it as a function of n? Well, let's see. If we're talking about the first term, we subtract 0 times. The second term, we subtract 1 time. The third term, we subtract 2 times. The fourth term, we subtract 3 times. So whatever term we're talking about, we subtract that term minus 1 times. So if we're talking about the nth term, we subtracted this value n minus 1 times. And you can verify that this is going to work. When n is equal to 1, this term here is going to be 0. So this whole thing's going to be 0. You get 9.6. When n is equal to 2, 2 minus 1, you subtract 0.1 one time. 9.6 minus 0.1 is 9.5. And you could keep doing that. You could draw a table and evaluate these if you want to. But the key thing is you're starting at 9.6 and you're subtracting 0.1 one fewer times than the term you're looking at. So if you're looking at if n is equal to, n is equal to 4, well, you're going to subtract 0.1 3 times. And you see that. Subtract 0.1 once, subtract 0.1 twice, subtract 0.1 3 times.